Hello everybody. So today I participated in, let's see in which contest. So I participated in Biweekly contest number 53 and I was able to solve all of them. A B C D and D. A B C and D. So let's start with the first problem. Let's see the what is the first problem saying. So here we are given a string S and we have to find the number of substring in which the three characters will be different. So this is very easy problem I say. So in this what we can do is we can just iterate over the string size and then we can insert the three characters, and if we have to check that if the set size is 3 or not. If the set size is 3, then we can increment the answer, and after doing all the loop process we can just return the answer. So let's move on to the second problem. So the second problem is saying minimize maximum pair sum in array. So let's see what the problem is saying. So we are given array of 2n integers, and we have to pair them in such a way that the maximum of the pair is minimum. So here is the example we can say. So here it is. So here we are given some array, and this is the array size will be even. It is given in the problem, the n is even. So we have to make such pair that the maximum sum of the pair is minimum. So what we can do is just we can just sort the array in increasing order, and after that we can just take the first and the last number of the array so that the sum will be minimum. So what we can just do is we'll loop through until while I is less than j, and we can just incrementing I and decrementing j such that j is decrementing and I is incrementing, and their sum will be minimum. So this is just we have to return the minimum sum. Let's go to the third problem. So the third problem took me a lot of time, so I will show you my rank here. My rank here is okay. It only took me 2 minutes to solve the first, 4 minutes to solve the second, and almost 45 minutes to solve the third because it is an implementation problem. So let's see what is the problem. So we are given an n cross m grid, and there are some numbers in the grid, like the first cell have some number, the second cell have some number, and we have to form a rhombus sum like this. We have to form a rhombus which will be inclined at 45 degree with the x-axis, and after and we have to take three of them such that their value will be distinct. And the if there are not three of them, just we have to print return one or two if there is less number of rhombuses that we can form with descending sum. So what we can here observe is, if we look in this rhombus, and if you can just see the my cursor here, this is just the prefix sum. This cursor that I am showing is a prefix sum of diagonally right element, and this this side is the prefix sum of diagonal left element. So what we can do is just we can just pre-calculate the left diagonals and the right diagonals, and then form a rhombus of increasing size. Like here it is in a rhombus of one size because this is side length is 1, so we can just increment the length side from 1 to maximum of n comma n, and just check their sum and insert it in the set to form a descending order of sum. So here what I am doing here is I am taking the left diagonals and the right diagonals, and putting the values in it with the grid values, and after that I am just, so this is the left diagonal sum, So left diagonal cell will be looking like this. If I just make a drawing here, if you can understand, if there are four elements like this, then the right diagonal will look like this. Okay, this is the left diagonal I'm saying, because I have adding I minus 1 and j minus 1. So if this is the I and j, and so we are adding the prefix value of the I minus j, I minus 1 and j minus 1. So this is the left diagonal value, and after that we are making prefix sum for the right diagonal. So right diagonal will look like this. So here will not, so diagonal will look like this. And after finding all the diagonals, after having all the prefix sum of the diagonals, we can just, so for rhombus size equal to 1, if the rhombus is just like a point, we can just put the grid values. And if the set size is greater than 3, we just erasing the front value, because means beginning value, because we have to find the top 3 greatest sum value of the grid. And this is just for, and I have done this just for debugging the code. Okay, so we are just iterating through all the cells. This is just iterating through all the cells. And for every cell of the grid, we are just increasing the rhombus size. We are just increasing the rhombus size, and then we have to take we have to take the sum of that rhombus if that is possible. And so this is full implementation part. You can follow up my code. I will give the code link, so you can follow up my code. So I have taken here like this. The first part is like the, I can show you like this, I comma j, and this is I minus k, comma, okay, this is I plus k, comma, j minus k. So this must sum is the, this diagonal I am taking, and also I am taking the right diagonal like this. This is like the I plus k, comma, j plus k. And I am doing this for same for the, okay, like this. I am doing the same for the down value like this. So this is the upper part, and I have done this in the this part. Okay, what is happening? Okay, this I have done in the upper part, and the down part I have done here in the second part. And this is like I plus 2 into k, comma, j. So this is the rhombus that I am forming with the prefix sums of the left and the right diagonals. And after that I'm just going all through. If that is valid, if flag 1 and flag 2, it is checking that if the upper part and the lower part is valid, then I'm just inserting the sum. And after inserting the sum, I'm checking that if the set size is increasing greater than 3. If this is increasing greater than 3, I have just to delete the first element, that is the smallest element, as I have to deal with only the greatest element of the 3. So after deleting the first element, I have just printing, I have just pushing the answer, pushing the elements of the set in the answer, and as the set values are in the increase order, I have just reversing the set. I am just reversing the array that I have to return, and then after that I return the answer. So this is just an implementation problem that took a lot of time to solve. After that I have, let's move to the fourth problem of the biweekly contest 53. So this is also an easy problem, level hard, but is easy for those who do dynamic programming. And the question is like this: we are given two arrays and we have to rearrange the second array in such a way that the XOR sum of the increasing index of the array is minimized. Like this, if I have given the first array like 1 to 3 and the first second array is like 3 to 1, then the XOR sum will be 1 XOR 3 plus 2 XOR 2 plus 3 XOR 1, it is equal to 4. So we have to minimize the sum. So what we can do here is, we can see that we can make a DP here, like the states of the DP is will be first index that range from, okay, 0 to nums dot size minus 1. So this is the first state of the DP, and after that we have to, the second state will be like how many elements that I have taken into account of the second array. So we can calculate it in like the bit form. So the second is how many of the second array I have taken. I have used basically used, how many elements are used are of the second array are used from second, okay, printing wrong, second array. So this will be the states of the DP, and after that we can just make the states like the n equal to nums to size, and the second state will be one left seat n, because for like let's take the example like one left seat n is like this. If there is one element, then what will be the state? So there will be total two states like 0 or 1. If the number of element is 2, then the states will be like 0 1 2, and like number of elements is like 3, the number of states will be like 1 left side 3 is 0 1 2 3 4 5. Okay, I am taking it 2 to 3 equal to 0 1. Okay, I have taken 1 element, 2 element, 3 element, 4 5 6 and 7 element. Okay, so this will be the like the states of the DP, and we are just iterating through all the indexes of the first array, and we are checking the number of bits that are available for the second array, and we are passing the nums1 and the nums2 array. I am saying that the number of bits available for the second array means that which element we are not take, which elements of the second array we have not taken yet from the second array. So you will understand if you look in the code. So this is the base condition, like the if the iterator goes out of the bounds of the first array, then we have to just return 0. So this is an unnecessary condition, because we can just return here 0, because it doesn't mind that the bit will have to be there, because the bit will go to the one left seed n minus 1 size. So it doesn't matter. I will tell you why I have done that. Okay, and if the state is already visited, then we can just return it. And after that we are just taking the answer as much as we can. Then after that we are just checking if that bit of the second array is set or not. If it's not set, we can take that element from the second array, and we are just zoring that element with the current element that we are iterating to the first array. And after that we are asking the recursion program to give me the XOR sum of the rest of the index that we can get. Like this, we are asking the re- recurrence to give me the sum, like I plus 1. And then we are just setting the bit. As I have taken that element, I have to set that bit to 1. So after that bit cannot be taken from other element of the first array. And after that we are just okay. Okay, then this is the end of the program. And then after that we are just returning the state with that answer. So why I have done that like that in here, as I was debugging the code, I was not getting what I was doing wrong. So the thing that I was doing wrong here was here. I was not putting a bracket here. So what it was doing, that it is taking this into precedence. And if you have read our precedence in operator, then you can see that the sum operator is a higher precedence than the XOR operator, and that's why it's taking this into consideration. And after that it is zoring with that element. So I have done here two penalties just for not putting the bucket, and just because I, I was I was aware, I was not aware of that that this has a higher precedence than that. And for that I have got two penalties in there. And just when only 12 seconds were left, I just submitted the answer, and boom, I got an AC. So this was the all the solution of the question that was held today. And see you guys in the next video. We'll be doing contest on Leetcode. So see you in the next video. And for that, if you enjoyed the video, just hit the like button and the subscribe button. If you want anything clearance, then just comment below. See you, tata, bye bye.